Hello everyone, welcome to our video on changing electrons, protons, and neutrons in an atom. Please take out your notebook so you can start taking notes. Have you ever wondered what happens if we change the number of electrons, protons, or neutrons within an atom? Well, that's what we're going to study today. Let's begin with the lightest subatomic particle of all, the electron, and see what happens when we change the number of electrons in an atom. Here we have a lithium atom, which is an unstable atom. It has 3 protons and 3 electrons. That means that it is electrically neutral. If we remove an electron, for example, this electron here just goes flying, then let me cover that electron. Okay, it's ready. So the electron already flew away. If we lose that electron, then we see that we have 3 protons and 2 electrons. So that means that this atom is no longer neutral. Now it has a charge, and this charge would be a charge of +1. And here we have it. Overall charge is equal to +1. How can we determine this number? Well, we can pair up the electrons and the protons. So for example, this electron and this proton will cancel out their charges. Same with this one and this one. And overall, we have a positive charge because this proton right here is left alone. So that means that when an electron flies and we're left with an extra proton, so to say, the overall charge would be +1, and we refer to this as a cation. A proper definition for a cation will be a positively charged ion, and the word ion means an electrically charged atom or group of atoms. In this case, our atom is no longer neutral, it is charged, so it is an ion. And what type of ion is it? A cation, because it's positive. Now let's take a look at our second example, which is an oxygen atom. Oxygen has the atomic number 8, so if our atom is electronically stable, we should have 8 electrons. So let's count the electrons in the oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. So we do have 8 electrons in our oxygen atom. And what happens when we add electrons to this oxygen atom? So let's add 2 electrons here. 1 and 2. This is our second electron. So we now have 2 extra electrons. So how does this look like? Well, first of all, we have to determine the overall charge. If our atom was neutral and then we add 2 negative charges, our overall charge will be -2 because again, we have 2 extra negative charges here. So overall, we have a -2 charge. And this particle, this atom, will be an ion because it no longer has a neutral charge. And the type of ion it will be called anion. An anion is a negatively charged ion. And here we have kind of like a diagram to summarize how we can form ions. We start with the neutral atom, and if we lose electrons, we will get a cation. If we gain electrons, on the other hand, we will make an anion. And just to wake you up, here we have a joke from Chemistry Cat. He's a cation. He thinks very positively. Let's go back because we already talked about the electrons, but let's go back to see what happens if we change the number of protons and neutrons. We're going to start talking about this together, then we'll analyze each case separately because they are both within the nucleus. So it's important to first understand what is going on in the nucleus. So if you start thinking about the nucleus, the protons have a positive charge and the neutrons have a negative charge. However, we have all the protons together in the nucleus. So how can we keep the protons together if without the repulsion between the protons keeping them apart? So there is a force called a strong force that opposes and overcomes the force of repulsion between the protons, and that's what holds the nucleus together. So the energy associated with the strong force is called the binding force. And the electrons are kept in orbit around the nucleus because we have an electromagnetic field of attraction between the positive charge of the nucleus that comes from the protons and the negative charge of the electrons that are flying around it. Now, in some atoms, the binding energy that keeps the protons and neutrons together in the nucleus is great enough to hold the nucleus together, so it is stable. In other cases, however, the binding energy is not strong enough to hold the nucleus together, and we would say that these atoms are unstable. Their nucleus is unstable, and unstable atoms will lose neutrons and protons as they attempt to become more stable. So let's keep on playing with changing the number of protons. We begin with a stable atom, and again we have our lithium atom. Now let's suppose that we add a fourth proton right here. So we no longer have 3 protons, now we have 4. We see that the number of neutrons and electrons stays the same. So because we now have 4 protons, the atomic number changes, and this is a different element. It's no longer lithium, it will be beryllium. Now, sometimes when the nucleus is unstable, as we mentioned before, this will become a radioactive particle, but we will talk more about radioactive particles as we move along this unit. We will discuss half-life, alpha particles, beta particles, radiation, and so on. So for now, I just want you to know that when we change the number of protons, we can have kind of like 2 different outcomes. We change the element, the charge also changes, and we can get a radioactive particle if this nucleus is unstable. And finally, let's see what happens when we change the number of neutrons. As always, we will begin with a stable atom. Here we have our lithium atom again. And we can add or remove neutrons. In this case, I'm going to add because I find it easier. So let's suppose that I add 1 neutron over here. When I add 1 neutron, we see that the charge still remains the same. We still have 3 protons and 3 electrons. However, because a neutron has a mass similar to that of a proton, we see that the atomic mass changes for this atom. So charge remains the same, and I just added that right here. The electrical charge remains the same, but we do have a change in the atomic mass. And this new particle will be called an isotope. An isotope will be, well, a pair of isotopes, for example, will be 2 or more atoms of the same kind that contain a different number of neutrons in their nuclei. Therefore, they have a different mass. So if we compare the atom that we had at the beginning, the neutral atom, it didn't have this extra neutron. And if we compare it to the one we have now, they're both the same type of element. So we have lithium in both cases. However, the mass is different. The atomic mass is different. Another thing about changing the number of neutrons is that when we add or remove neutrons from the nucleus, we can get an unstable particle. So radioactivity is also part of this removing and adding neutrons to the particle. And again, we will discuss radioactivity later on. And isotopes will be our next topic. So for our next video, you can expect to learn more about isotopes. For now, that's it. We learned what happens when you change the number of electrons, protons, and neutrons within an atom. So I hope you enjoyed the video, and I'll see you later in class.